Hello everyone. Today I'm going to talk about how to model uh, thin parts or bodies as shell. Especially this is a very beneficial practice when we are dealing with thin parts or bodies for heat transfer analysis or fluid flow analysis, because it's going to save time for meshing and it's going to be easier to mesh, and as a result it's going to save computational time. And this tutorial is going to be beneficial for both Ansys Thermal and Ansys Fluent. So everybody who is using those tools can get benefit from this tutorial. Before going ahead, please go ahead and subscribe to my channel so I can make more these videos. So here I'm presenting a geometry which consists of three parts, well, four parts basically: the base, two fins, and this volume, which can be a fluid volume or solid volume. I'm gonna hide this. So the first step is to create a shell or surface for this fence. So the way to do it, go to prepare and select mid surface. And I usually select the range because that's easier. And this thickness basically is gonna search all the parts which has thickness less than this, and it's gonna create shell. So the second important part is the default is set here on the for the middle. So it's gonna create a shell or mid surface from the middle of part, and we don't want to do it because we want to touch the shell to this base. Otherwise it's going to create a gap and it's going to be hard for meshing. So depending on the orientation of your fins, you need to select bottom or top. Here I select bottom and then select this guy, and the green part is a part that basically is going to be our shell and it's going to touch our base. So I say okay, and as soon as I do that, it's gonna suppress the fins because we don't need it anymore. Basically it's gonna be converted to a shell. So I'm gonna do the same thing for this guy. So as you can see, these two shells are touching the base, and that's what we want. The second step is because usually we are doing this analysis for heat transfer, it's better to have a shared topology. So we're gonna do shared topology. So we're gonna go to workbench and then share, then okay. So we are good to go. And then next part, I'm gonna transfer this to the mesher and then I'm gonna mesh it there. So to save time, I already meshed it. As you can see, it's a conformal mesh because we use shared topology. Also, please note that those two shells are shown as shell here to make sure we did everything correctly. If you want to do an Ansys thermal analysis, here you can put the boundary condition and run it, and it's going to behave as a shell. Also, if you want to do a parametric study for the thickness of this shell, you can change the thickness, and it's going to change the thickness in the solver. But here our goal is to go to Fluent and run our analysis there. One other thing to note is to visualize this. So here clearly it shows as a shell, but if this guy thick shells are on, it's going to show as a solid part. So don't get confused, it's not a solid part, it's just going to show the rest of the domain. So just turn off this guy, so it's going to show at the shell. The other important point is we have to do a name selection for these shells, otherwise it's not going to show it properly in Fluent. And also don't forget to put wall in the name selection, so Fluent knows this is a wall. So with that, I'm gonna go to Fluent and see what we see there. So I transfer the mesh to Fluent, and the first thing to do is go to boundary condition and check the walls. So you see some boundary conditions here. So the baffle, we display it. Basically, it's a base of fins, and for some reason it didn't separate it from our fins, which is fine because it's placed on the base of the our geometry. It's not gonna cause issues because the important part is these fins that we want to know the heat transfer role basically there to see the effect of thickness. So the next part is to turn on the energy equation here, and then go to physics and conduction manager. So the cool thing about the conduction manager is you can do multiple selection, and it's going to apply the settings for you. So for example, here we select this baffle settings, and we click on shell conduction, and then we can put a thickness. Let's put like 1 millimeter, and here setting, it's already to 1, but we can change it to 2 millimeter. For fin 2, again, we can change it to whatever we want, 3 millimeter. So now everything is set. You can load the rest of boundary condition and continue your simulation. I'm not going to go to that because I assume you guys already know. That was a part that I had difficulty to find it, and I thought to share it with you guys. One other thing is you can set the shell thickness here, but don't forget that don't mix it with the wall thickness, because this is different from shell thickness. Because if you put the thickness here, basically it's gonna add a thickness to a wall. If you have a wall, if you don't have the wall, in this case, it's just gonna consider the conduction in the thickness of wall, not in the both not on the both x, y, or planar direction. So don't forget that this point, and don't put it here. You need to check shell conduction and then edit, and you can put the thickness here. That's it for today. Before going, don't forget to subscribe to my channel so I can make more of these videos. Thanks for watching.